Good morning to all the students. Today we do the practical on design of the limit gauges. The limit gauges. The theory behind the limit gauges is limit gauges ensures the component lies within the permissible limit and determine the actual size of the dimension. The gauges required to check the dimension of the component with reference to the two size confirming the maximum and minimum limits. So this is the diagram which shows the two types of the gauges, that is the Taylor principle, that is go gauge and not go gauge, that is go gauge and no go gauge. The introduction of the gauges. In mass production component, the tolerance limits are suggested by the designer for the interchangeability. The various measuring instruments are used to measure the actual dimension and compare with the standard specific dimension. In mass production, the gauges are used to check the compliance of the limits. The limits gauges are ensured to component lies between the permissible limit. The gauges are scale less inspection tools. The go gauge and no go gauge are not gauges which corresponds to mml or LML components of dissipated in the figure. Maximum, minimum limits or lower minimum limits. So this is the diagram which shows the MML, that is the go gauge, LML not go gauge. The next diagram shows the metal conditions related to the hole gauging, and these diagrams can be explained the system, that is the go gauge. This is the part which is related to the go portion and this is the part which indicates the no go gauge. The go gauge manufactured to the maximum limit with the assembly of mating part. Not go gauge corresponds to the lower limit and it will be not. Hence the name go and not go. That is, this diagram is 47H7, that is go gauge, and 50H7, that is not go gauge. So go gauge means this portion, that means it is go through the gauge, and this portion is related to the no go gauge, that is 57H7, that is not go gauge. The important points for the gauge design. The gauge design should be replica of the mating parts. The go gauge enables the several relative dimensions to check simultaneously. In inspection, the go gauges must be put into the condition of maximum impossibility. The inspection not go gauge must be put into the condition of maximum possibility. The material for the gauges. The hard and wear resistance corresponding resistance material are used for the manufacturing of these gauges. It has a low coefficient of expansion. The material generally used are high carbon steel, mild steel or chromium plated. The gauge tolerance, that is a gauge maker tolerance. The gauge maker tolerance, it is 10% of the work tolerance. The wear allowance. The not go gauges are very rarely engaged with the workpiece and therefore the wear allowance is there. Hence, to provide an allowance with a wear in the case of the not go gauge, the 10% gauge tolerance is also acceptable in industry. There are methods of tolerance specification in the gauges. The present British system, it is an occurrence with Taylor principle and that is widely accepted in the industries. This is the methods which is related to the specification of the go gauge and non-go gauge, in which the minimum hole dimensions and maximum hole dimension size are given. In minimum hole dimension size, there is a direction which is related to the not go gauges, and maximum hole size dimension is related to the go gauges as well as not go gauges. The method of tolerance specification. From the above figure, the tolerance zone related to the go gauges is placed inside the work limit and not go gauges is outside the work limit. The margin is provided in between the tolerance zone for the gauge MML work accordance with the wear allowance. The wear allowance should not be permitted beyond the maximum measuring limit of the workpiece. On this base, we have to solve a numericals. That numerical is related and that numericals can be completed in your theory classes. The design, the general type of go and not go gauges as per the British system. for 40 millimeter shaft and hole pair designated as 40H8D9 given. The formula which is related to the I, that is 0.45, it is a common formula. All the students remember that formula. The 40 millimeter lies the dimension, that is the range is 30 to 50. I standard for H8 is IT8, that is 25I, and D9, that is IT9 is equal to 40I. The upper deviation of the shaft is minus 16D raised to the power 0.44, and wear allowance is provided is 10% to the gauge tolerance. So for solution, the dimension is given with 40H8D9. The standard dimension for 40 millimeter shaft is ranges to 30 to 50. So you are find out the one diameter, that is the D is equal to under root of D maximum into D minimum. With respect to this formula, the value of the D is 38.7298 millimeter, and you are giving the fundamental tolerance unit, that is I, 0.405. You have to put the value of the D in that D and you will get the answer, that is 1.571 micrometer. The whole quality H8, the fundamental tolerance is related to 20I, that is 39.275 micrometer, that is 0.039 millimeter. All the dimensions are converted into millimeter. For hole, the fundamental deviation is LLH is 40 millimeter, HLS is the addition of that micrometer level in, that is H8 fundamental tolerance is 0.039. This tolerance 0.039 is added with respect to this high limit for the hole, that is 40 plus 0.039 is equal to 40.039 millimeter, and hole tolerance is related to 0.039 millimeter. After that, for shaft, that is D9, the fundamental tolerance is 40I. 40I, that is 62.84 micrometer, that is converted into millimeter, and after that converted is 0.063 millimeter. The fundamental dimension for the shaft is given, that is minus 16D raised to 0.044. You have to place the value, the limit is minus 0.080 millimeter. Therefore, the highest limit is 39.92 millimeter and lowest limit is 39.857 millimeter. Therefore, the shaft tolerance is 39.92 minus 39.875, that is 0.063 millimeter. Therefore, the whole tolerance limit, that is unit tolerance limit plus 0.0039, and shaft is having a bilateral tolerance limit, that is minus 0.080 minus 0.143. So this is the diagram which describes the hole based system and shaft based system. The limit is 40 and lower limit is 0.039. The fundamental deviation is 0.08, therefore it is placed in between, in below, and its value is 0.06, and the zero limit is 40 millimeter. So all the students understand this diagram, how this diagram is come. This diagram is come with respect to the above calculation. The high limit for the hole is 40.039 millimeter and lower limit for the hole is 40 millimeter. Therefore, lower limit is drawn with respect to this zero line and higher limit is drawn with respect to the hole dimension. After that, you are getting the high limit for the shaft, that is 39.92, and lower limit for the shaft is 39.875. So fundamental deviation is find out with respect to the shaft, that is 0.080, that is the difference between these two limits, and it is given as 0.06. After that, we are providing the gauge tolerance. In your questions, the gauge tolerance is 10% of the work tolerance. That means 10% of 0.039. The wear tolerance is 10%. So it is also reduced with respect to 0.0039 millimeter. It is for a hole. After that, the gauge tolerance is provided to the shaft. It is in the same way with the gauge tolerance of the hole. That is, gauge tolerance of the shaft is 10% of 0.006 and wear tolerance of the shaft is 10% of 0063 millimeter. The design of the go gauge. Now we come on the design of the go gauge. So go gauge basic limit is basic size plus wear allowance. The wear allowance obtained is 0.0039. Therefore, the lower limit is 40.00039 millimeter and the higher limit is addition of wear allowance plus gauge allowance. That is 40 plus 0.00429. That is 40.00429. Therefore, the go plug gauges having 40 plus 0.00429 plus 0.00329 millimeter. The design for the not go gauge. The same dimensions can be related, but in that higher limit, the basic size is added with the fundamental tolerance as well as the gauge tolerance. Therefore, the limit not go plug gauges is 40 minus 0.0429 plus 0.0390. So this is the basic dimensions which is related to the not go gauge for the shaft and go gauge for the shaft. So in this way, the diagram is dissipated with related to the gauge tolerance and wear tolerance for go gauge or not go gauge. So in this way, we are conducting the practicals of our university syllabus related, and which is helpful to understand the concept of mechanical measurement. In mechanical measurement, there are two parts. First is the introduction and description and working of the instruments, and in another part you have to study the various types of the instrument with their measuring concept, with their measuring parameters. That is, first is measurement and second is metrology. So in this way we are completed our 8 practicals, and these 8 practicals can be given to your manual. Complete that manual and submit that manual within the deadline. So thank you.